All right, thanks. So you're in the session Mixed Reality with Microsoft HoloLens. I'll skip that slide because Lars just told you to use the app. So my name is Philipp. I'm the founder and CEO of medialesson. We're a small consultancy based in Germany, which explains my strange accent and my sometimes inability to speak proper English. I'm also a Microsoft Regional Director and 4 times Microsoft MVP, which doesn't mean I do work for Microsoft. I'm a full independent expert, but obviously we do partner a lot with Microsoft. So today we want to talk a little bit about mixed reality and HoloLens. So that's our roadmap for today. I want to kick off with just some general remarks on mixed reality, how it's positioned in the universe with virtual reality and augmented reality. Then we'll have a quick look at the hardware. That's kind of the centerpiece of the experience. I will try to do a live demo on stage, which is always kind of risky with this device, but we'll see how that goes. I will show you some real-life use cases that are built today, and then we'll talk sometime about the developer story that's behind HoloLens and all the options that you have if you want to go into the area of mixed reality. And hopefully we'll have some time left after my talk so that some of you get the chance to actually try it out, because it's a huge difference between seeing videos and images and me talking about the experience than to actually really wearing the headset and having the chance to try it out. So I have brought with me 2 devices, and I will also be here during the break, so hopefully a lot of you get the chance to actually really try it out. Okay, let's start into mixed reality. So if we talk about the headsets like the HoloLens, it's first of all important to understand that it's not so much about the technology of visualizing stuff, like how much resolution does the display have and things like that. The trick really is in the sensors, the spatial understanding, the environmental understanding that this device actually offers. So let's sort that out. Mixed reality is kind of a new buzzword that has been promoted by Microsoft, which really means the blending of the virtual and the real world. So let's dig a little bit deeper in that one. So we have obviously the physical reality with all our real world objects as we as humans sense it. And then for a lot of years already, we have the virtual reality with various devices like the HTC Vive that offer us a full virtual environment. Virtual world can take us anywhere we want. We can have virtual objects of any size and kind and do whatever we like in this world. So the idea really is to bring those things together for a mixed experience that is not only about blending the physical and the virtual world, but also about understanding between the 2 worlds. So they really fit into each other. So when we look at the virtual reality, as most of you might have already experienced on those devices out there, we are full virtual. We can do whatever we like, but we cannot see the real world anymore. So each of us who is wearing a headset like that is kind of stuck in his own virtual world. This is really nice because it's very immersive, so it's great for gaming and entertainment. It's not so nice if we want to actually get things done, right? Because if we want to work with a device, we still need to collaborate with other human beings most of the time. We need to be able to interact with our customers and clients. We might want to construct something with a group of engineers. So virtual reality is not so great at that because if I cannot see another person, it's really hard to interact with it. There's virtually no real communication possible. And then on the other extreme, if we look at augmented reality devices out there, like maybe Google Glass or handheld-based systems, it's really about augmenting a digital layer into your world. It's like a head-up display in your car or in jet. So it's giving us an extra digital information layer, but it's not truly interacting with the environment. When we go over to the mixed reality, though, it's really about integrating and responding to the real world. So the device has an understanding that there's a floor I'm standing on, and I can apply physics to my holograms. So if I drop a ball on the HoloLens, it can bounce back from the floor because the headset actually knows there's a floor, or it knows about furniture, a chair and a table, so it can really interact. And this offers some really nice opportunities. So for example, if I want to have a TV on my wall wearing a HoloLens, I just pin a 2D pane onto that wall because the HoloLens understands it's a wall. I can pin things against it. They stick to it. They can really lock on the wall. Or I can have virtual objects really sitting on my table, not falling down, not being like halfway in the table, but really sitting on top of it, no matter where I'm moving. So what actually is a hologram? For me, it all started with Star Wars, having Princess Leia being able to communicate through a hologram. So it's basically like any other object in my real world, with only one difference. Instead of being made of physical matter, a hologram is made entirely of light, obviously. So it has some physical limitation because it's made of a lot of light. There is no color black, for example, because what light would black be? So if I'm having something black in my virtual world wearing a HoloLens, it becomes completely transparent. I can see through, obviously. So having the color black is really hard in a hologram. And because holographic objects are really mimicking the real world, I can view it from different angles. So it's really locked in my real world. It's anchored. So I can walk around it like with any real object. I can view it from different sizes and angles. This is really interesting because it gives us a different approach, different connection to virtual objects. If you imagine you're learning the human anatomy with a hologram, it's a huge difference if you can actually view it from different angles using your own body than using a controller. It gives you a much better sense of proportion and size and dimension, and gives you way more insight than traditional 3D technology. And, well, obviously, holograms don't offer any physical resistance. So if you touch them or push them, you won't have any feedback. There are a lot of people working on this issue with special cloths that offer then electronic feedback, but I think we're not quite there yet. So another view on the market would be dividing up the device categories between desktop performance and mobile performance to really see where holograms and HoloLens fits in. So on the horizontal axis, we have desktop versus mobile, and on the vertical axis, we have physical reality versus virtual reality. And most of the professional-grade VR devices nowadays would be on the lower right corner, right? They're attached to a real PC. It has to be a really powerful machine, a lot of graphics, GPU power, and they're fully closed. You don't see the real world. And then on the other side, there are a lot of portable VR devices on the market in the lower left corner that would be something like Samsung Gear VR or Google Daydream. And then HoloLens positions itself in the top left corner being very portable, and I come to that in a second, and being really see-through devices. And this is, besides the sensors, the spatial understanding, being a portable device is a real differentiator for the HoloLens because it enables a lot of interesting scenarios. Since it's not tethered to any PC, it's its own self-contained computer, you can really have a very robust experience. You can just carry it around to your client, go into his empty construction site, put it on, and start planning right away. You don't need to pre-scan the room. You don't need extra sensors being set up. It's all built into the headset. So if we compare it to augmented and virtual reality, it kind of gives a lot of the same features. It allows us to augment the real world with helpful information. Obviously, we can just have simple head-up layers in HoloLens as well. We can blend holograms in your real world. And then one thing that's very little known about HoloLens is it also has some sort of a VR mode. So there are certain apps like, for example, HoloTour, where you have so many holograms in front of you, it really closes your field of view, so you're completely in a VR environment. But obviously, it doesn't completely replace the real world like a virtual reality device would do. So let's have a short look at the hardware. The HoloLens itself, as I said, self-contained computer, which basically means everything that it needs is built into the headset. It has a CPU, a GPU, it has RAM, it has persistent storage. It's basically a Windows 10 machine. And then it adds up with all the sensors. The sensors are used, first of all, for the spatial recognition. So it's scanning the room to make an architecture spatial map of it. It's using the same depth sensors that were introduced with the Kinect camera, and also has an RGB video camera sitting in the middle of it, actually watching your hands and allowing you to take screenshots and videos of the field of view. As you might imagine, we need to have some sort of a display. Those are the transparent lenses. They have a fairly low resolution. They're only running at 720p. That's very low if you compare it to an HTC Vive or Oculus Rift. But if you try it out your first time, you will see the holograms itself are crystal sharp. It's a really nice piece of hardware. And then, obviously, some sort of silicon that actually does all this complex processing. If you see how many sensors the system has, there's a lot of sensor data that needs to be processed and interpreted. And therefore, the HoloLens has a third computing unit. It's called the HPU, the holographic processing unit. It's a dedicated piece of hardware that does all the sensor calculation, takes all the raw sensor data, and provides us useful meaning out of it. It also does all the gesture recognition and voice recognition in the system. Another very important component of the HoloLens would be spatial audio. If we look at HoloLens and watch all the videos about it on YouTube, we will see it's almost all the time about the visual experience. But if you want to have a true immersive experience, you also need audio. Audio helps you actually identify the location of objects in the room, because most of the time, an object, the hologram, would not be in your field of view. It might be behind you, left, right, wherever. And using spatial sound, you can actually guide the user towards a hologram and gain his attention. And it's done through those two little red speakers that allow you also to hear your real world, so you can still interact with other humans, which, again, is very important if you want to use this device in a professional environment. And right now, it's clearly the direction where it's positioned towards professional use. Interaction, also very important because very different in a HoloLens. We have basically three systems of interaction using the HoloLens. The first one would be gaze. Gaze just basically means where I'm looking at. And it's like, if you imagine you have a little laser pointer that's mounted on your head, it sends out a ray, and wherever it collides with your real world or your virtual world, you will get a 3D pointer at this position. So it's basically a mouse in 3D. Wherever you're looking at, you can see where it collides and then interact with the object. Then to do some sort of interaction, you have gesture that are usually combined with the gaze. So you're looking at a virtual or real object, and then you do a gesture. And the most common gesture in the HoloLens would be the air tap, which is just your finger and doing like this. This is kind of the mouse click. There are some other gestures, like the bloom gesture, for example, to actually spin up the Windows Start menu, but the click really is the most important one. And then the third system would be voice commands. So we have a built-in microphone array like the Kinect has. So we have very, very good voice recognition built into the device. And if you design your HoloLens application, it's really important to determine your audience and then decide whether you go for voice or gesture or a combination of both. Because there are certain situations where the gaze gesture system will be very good because it's precise. For example, in a professional environment, you have some people that use the device on a daily basis or on a regular basis. They're used to using gaze and gesture, so that's very efficient for them. But if you have, on the other hand, an application that's more public-facing, like for a theme park, for a trade fair, where you put on the HoloLens for people that have never used it before, they have a hard time learning gaze and gesture. It takes some minutes to adjust to it, so it might be more efficient if you're using voice commands for these situations. So to give you a first overall impression how the device feels, I have one little video that I wanted to show you to set you all on the same page here. Let's see if it works.
Microsoft HoloLens brings holograms into your real world. Using transparent lenses, spatial sound, and an understanding of your environment, holograms look and sound like they're actually part of the world around you. That is mixed reality. With Microsoft HoloLens, holograms are viewed through the holographic frame centered in the middle of your view. This preserves your peripheral vision, so you can move freely and connect and collaborate with people around you. Holograms in mixed reality don't block out what you can see and hear. This enables you to engage with digital content and tools alongside the objects in your real world. Holograms can be world-locked in a physical location, so you can walk around them, or they can travel with you. You can even hear them in 3D with spatial sound. Microsoft HoloLens is the world's first fully untethered, self-contained holographic computer. With the mixed reality experience of HoloLens, you can stay in the real world and interact with real people as you simultaneously explore 3D in 3D.
Okay, that looks impressive. Looks like a lot of post-production, right? So one new information that's really important that came up in the video is the holographic frame. So in some of the shots that were in the video, you could see that the actual holographic experience isn't like full screen, fully immersive all around you. There's a certain frame in which you can see holograms, and there's a lot of space around you in your field of view where you don't see holograms. This is because the lenses actually have a certain area here where the display is sitting, and that's basically like a little display that's sitting in front of you, so it's not as immersive as you might think when you're watching especially the very early videos dated of the HoloLens. So the holographic frame is one piece that you might find surprising when you're first wearing the HoloLens. Okay, so to sum it up, we have a device that supports mixed reality and virtual reality mode. It's in the core feature would be spatial mapping to actually really understand the environment. And you have seen that in the video a little bit where it has this little mesh that was drawing all around the room with the polygons. You can actually do that on the HoloLens if you just click around you, where you have no application open, you're wearing the HoloLens, and just click around, you can actually visualize exactly the spatial mesh that's going on. It's fully untethered, runs Windows 10, and has an interaction model using gaze, gesture, and voice. So now comes the fun part for you, maybe not for me, to actually try to show you live how this feels. What I'm running here is the HoloLens companion app. It's just a very simple Windows 10 app that connects to a HoloLens. And let's see if that works. Give it a little second. Okay. Oh, went online, that's a good sign. So you will see it has a little bit of a delay because I'm connecting to the HoloLens through my iPhone hotspot. So So it's not really a super professional wireless I'm using. So we have a little bit of a delay. But you can see I have the main menu actually floating in front of me. That's kind of the HoloLens version of the Windows 10 Start menu that I can bring up and hide using the bloom gesture. So if I do the bloom gesture, it's gone. If I do the bloom gesture again, here it is. So let's see. Before the session, I already pinned 2 apps here. You can see those 2 windows. Those represent apps that are currently running. And so if I click on one of those guys, the app should actually load up. And here we are. This is a demo version of an app that's used for the education of doctors and giving them some anatomic insights. So this is basically a hologram that's super stable. So if I move around very fast, it's rock solid. It doesn't move around in space. It's like a real object. And one very cool thing about holograms is if I'm getting very close to them, and I need to look on the screen a little bit, actually they open up at a certain distance. Let's see. So I can really look inside what's going on in this human body. You as a developer, you can actually adjust the distance when holograms open up. So the standard distance would be 85 centimeters, but you can control it. So this is a very basic application that doesn't have a lot of interaction in it, but it actually gives a very good idea about how HoloLens feel in the real world. And although it might look very immersive on the preview screen, actually in my field of view, it's like it's approximately this size, and everything around doesn't have holograms. So if I want to see something up here, I really need to move my head a lot to actually explore the holograms. But usually people adjust very fast to this behavior. So the other very nice thing is the spatial mapping visualization. So if I go out of this app, and then let's see when the preview picks up to it, I then click, for example, on the floor. You should see the polygon outline. So you can actually see what the HoloLens is actually seeing and how it's recognizing the room. And as I move around with my head, I can really see how it's scanning the entire room. There are certain limitations on the distance, so it doesn't scan things that are more than 6 meters away from me, but in a normal office setting, I can scan the entire room. And it saves the room profile. So if I place holograms in this room, and I go elsewhere and come back in 2 hours, it will reload all those holograms on their original position that I placed them. All right, let's see if I can back to slides. Oh, come on. Here we are. Quick look at use cases that are out there. As you know, the HoloLens is not really a consumer device right now. It's available as a developer edition, priced around $3,000. And then there's a commercial edition that comes at $5,000. So its use cases are clearly aimed towards professional use, and there are actually quite a lot of them. Oops, why is it flickering? Did I make something wrong? Oh, okay. Hopefully this works. Stop soon. Okay. Well, let's go on. So if you imagine marketing and sales, you want to sell a complex product, maybe on a trade fair or in a car saloon, and you want to visualize things that are not on the outside of a product, like, for example, how the engine works, how certain digital systems work. It's a really nice way to bring those content up and to have some sort of a view inside of a product. Obviously, product design. So if you're actually working on products before printing them out in 3D, you might want to use a hologram to really construct it. And then for education, obviously, we've seen that with the holoanatomy sample right now. It's a really nice way to educate about complex complex content. Then there's architecture, and this is an interesting case. We kind of prototyped that for ourselves a couple of months ago. We've been moving into a new office space that was completely empty. There were no walls inside, just a basic building structure. Oh, now it's gone. I'm sorry about that. And we wanted to figure out where would we put walls, how would the room feel if we put a wall here or there, where would we need extra windows, where we want to build glass. And we actually constructed a very simple app using Cinema 4D and Unity, where we can just place walls in the empty space. And you had a really nice impression of how the room would look like without actually constructing it. So those are scenarios that work extremely well. Or another use case would be your manufacturer of a complex machinery that is part of a larger production line, for example. And there are machines already placed on the shop floor before or after the machine you're actually building. And you go there with your client all wearing HoloLenses, and you can actually place the machine in real size and see if all the connectors fit, if it works in the right space. Remote servicing, there are a lot of use cases already doing that, so allowing people to help me remotely, so having the engineers not going on site, but shipping HoloLenses with complex machinery. There's research with NASA going on Mars. Games and entertainment, obviously not quite there yet. And then semi-virtual construction is one of the use cases my company is currently working the most on. So you're having a certain machinery or cars that are built in parts. You have just a chassis, for example, and you want to simulate the real lights, or you want to simulate certain accessories on a car. That's a really nice use case using the HoloLens, because it can actually identify the object and then precisely build holograms on top of it. And then there are a lot more. Okay, I'll skip over that one. So let's see how we actually build applications for mixed reality. And right now we have quite a choice of options there. So for start, we need to actually choose what kind of application we want to build for the HoloLens. There are basically two types in general. There's a holographic view, and there's a 2D view. And we've briefly seen this in my demo, where I had the two representations of the apps that were actually running already as 2D panes. And then as soon as I clicked on one of those app instances, it got full screen and offered me a holographic experiences. And actually, I can do both and mix them with the HoloLens. And let's have a look at those two. So if I go for the holographic view, obviously I get holograms, and I get some sort of full screen experience. I'm the only app running at the moment. We can render world-lock holograms. We can really anchor them and persist them across holographic sessions. We can even export those world-locked holograms and copy them to other HoloLens devices. So we can set up an application experience with a room with one device and then spread it out to multiple devices. Shell doesn't render, so the menu is not there when it's running, and the app is handling all the user input. And then we have the 2D view, where we're rendering on a 2D pane, and we can world lock those slates. We can adjust them in size and position. And the cool thing about it, it's basically every UWP desktop app can run in one of those 2D panes. So there are already hundreds of thousands of apps for the HoloLens that can run in 2D mode. So you can now already just download Netflix from the store and then pin it on your wall and have a 200-inch Netflix display on your patio, if you like, or some sort of outdoor space. That works already. Apps resolution stays fixed right now, so it's not, you cannot have Excel with like 1 million columns all around you. It's always the same app size. You can just scale it in itself. So those are our basic two options, and obviously the holographic view would be the most interesting part. So if you go down the holographic path, we have a lot of options how to do that in respect to technology. So right now the most popular option would be to use Unity. Unity is a well-known 3D game engine basically a middleware to write cross-platform 3D content, apps and games. It has probably the best productivity across all your options you have, because you have a visual editor you can use to offer your apps. You have the biggest community out there, most platform support. Right now with Unity 5.5, it's actually built into Unity to have HoloLens support. And it's free for personal use, obviously. And right now, around 91% of all apps that are out there are built using Unity. So that's by far the most popular way. But there are other options too. So if you want to be really hardcore, you can go direct 3D using C++. So you can go bare metal. You can skip the middleware, you can skip Unity. That will offer you some performance gains, but you have to take care of everything yourself. Very low platform support, so you have to write a lot of stuff yourself. You can also obviously use C# with a SharpDX wrapper around it for C++. Then there's EuroSharp. That's a project by Xamarin. So that's another way of writing apps, cross-platform 3D apps using C#, just another middleware option. And then if you're coming from the web stack, there's actually HoloJS. That's a JavaScript HoloLens framework that's out on GitHub by Microsoft that allows you to write holographic apps using JavaScript and WebGL. And then obviously you can do pure UWP using XAML, C#, VB, or C++ to write 2D view apps. So those are, in general, all the options you have. The tooling is, in most cases, or in all cases, free. So you will need Visual Studio 2017 or Visual Studio 2015 update free. They are free as a community edition. You can just go ahead and download them. You will need Visual Studio to compile your UWP app. And actually, if you want to deploy on a real device, or if you want to deploy on the HoloLens emulator, you also need Visual Studio. Which brings us to the HoloLens emulator. That's a complete virtual machine with HoloLens running on it. You can use to actually develop holographic applications without having the real hardware, which, again, is kind of pricey right now. So HoloLens emulator, you can start right now. Then you need Unity if you opt to use this middleware, also available as a free personal edition. And we have the holographic toolkit that's out on GitHub. The holographic toolkit is actually a collection of pre-made components that you will typically need if you're using HoloLens. For example, you get components that do spatial processing, that do spatial audio, that handle input, that recognize gestures, so that a lot of low-level stuff gets out of your way, and you can really focus on your content. So that's a really good stop to actually check out the toolkit before writing your own stuff. And then there's another very interesting framework that we've been using recently a lot. It's called Vuforia. You might know it if you have done already iOS or Android 3D games. It's very popular there. It's basically a framework to do marker-based recognition in video signals. So if you're looking at a video feed in real time, either through your smartphone or through your HoloLens, it can recognize 2D markers, like a QR code, which is not super exciting, but it can also recognize 3D objects that you can train into a model, and it can be re-recognized. Now, you might be wondering why you need that on a HoloLens, because you have spatial mapping, and spatial mapping does all your room recognition. But there might be a lot of things in your room that are not suitable for spatial mapping. For example, because they're very small, or they move around in the room, like a car or a little piece of equipment, and you want to really precisely track that and put holographic content on top of it. So for example, again, you're on a shop floor, and you're picking material out of a box and then having to place it somewhere specifically on a car. You might need Vuforia to actually have the precision into moving objects to augment that in a proper quality. So that's where Vuforia comes in. So the typical development workflow would be you would actually create your scene, all your content using Unity, and then you would build your project into Visual Studio 2015, where it's a UWP app, and you then compile it there, and from there deploy it on either your device or on a HoloLens emulator. Now, this is a process that takes, even if you have a real decent machine, that takes a lot of time. So doing the whole cycle here, it takes literally a couple of minutes. So it's not very efficient if you're kind of in the beginning of your project, just want to quickly iterate. So there's a new way of doing it with Unity 5.5 that's called holographic emulation, right built into Unity. And this is very interesting because you have two options here. You can either do a simulation or a remoting. A simulation means you actually have holographic features running live in your Unity editor. So if you hit play in Unity, you can load a certain room profile, you have the spatial data, you can use a gamepad like an Xbox controller and simulate your HoloLens movement in your scenery and really quickly iterate without ever leaving Unity. Or if you want to test out on a real device, you have holographic remoting, which means you install a little companion app from Unity on your HoloLens device and then deploy in this companion app without going through Visual Studio, which again makes it a lot faster. Also has some limitation. It kind of has impact obviously on performance because it's running sort of a virtual machine. In case you're doing a lot of Vuforia or third-party stuff, it might have limitations there as well. So this is a quick sample how it looks like of doing this simulation in Unity. So you can see the polygon area. You really have a virtual room, and you can move around with your gamepad controller without deploying on a real device. So as I said, we've done a couple of projects in the last month, and they're like the top 10 learnings we had from this project that if I knew in advance would have saved me a ton of time. So I want to share those with you. First of all, HoloLens really is a mobile device. It's not like the HTC Vive. It doesn't have a super fast computer with a decent GPU in behind. So it's more, performance-wise, it's more like having a tablet computer or a smartphone. So this has a lot of implications. Obviously, you have to make really sure that you don't drop below 60 frames per second. If you drop below 60 frames per second, holograms start to move around in a room. They're becoming unstable because the recalculation doesn't work anymore. You really have to stick to 60 frames. So this limitation really has impact on how many polygons you have in your scenery, which shaders you can use, how you handle things like Vuforia, for example, or shadows. So in our experience, if we go into models that are way beyond 100,000 polygons, it's not going to work in the HoloLens. And if we talk with our clients, they usually come up with, hey, we have this CAD model of a car or whatever. It has 4 million polygons because it's like the complete car, every screw and everything of it. And this doesn't work right away on a HoloLens. It doesn't work right away on any device, but especially on a HoloLens, you really have to recreate content. And this is a massive effort, and really have to take that into consideration before you start any app for HoloLens, is how you will handle content and make sure it works nicely on HoloLens and gives you the right performance. And for example, things like Vuforia, they take a lot of CPU time. So if you use Vuforia to track an object, we quickly turn it on, we see the marker and then turn it off right away, and then move the position that we get from Vuforia into our spatial model, and then let the HoloLens HPU, the holographic processing unit, recalculate the position changes. Number 2 would be, don't forget to anchor your holograms. That sounds trivial, but actually you have to explicitly do that. So if you place something in your world, it's not automatically anchored. And if you forget to anchor, you don't immediately recognize it. It still stays kind of stable, but as you keep adding stuff to your project, things are getting unstable and start to move around. So you have to explicitly think about how you anchor your holograms, and there are different techniques you can do about that. I did provide a lot of links, so you might want to dive into that one as well. Use existing tools and pattern. So the problem or the challenge with HoloLens would be that it's a fairly new technology. There's not a lot of best practices out there, how to do interaction, how to do input. But there are some, design guidance by Microsoft, and there's obviously things like the Holo Toolkit that you can actually use to not reinvent the wheel all the time. You don't have to generate your own gestures of doing things because people have a hard time learning that. You should stick to the basics at the beginning. And then leveraging spatial audio. That's kind of underestimated all the time in every project. You really have to convince people of doing it, but it adds a lot to the experience. So you could have just a visual marker in your scenery saying, turn right to continue, or you could have an audio source that's coming from your right ear that guides you towards it, which is way more natural than having any sort of artificial visual marker in your field of view. Choose the right input mode for your audience. I did already briefly talk about that. If you have a public-facing application, you want to really go with voice commands, versus you have a professional application with frequent users, you go for gaze and gesture. That's a small one, but it's a really annoying one. So if you're doing Unity development, you typically have more than debug and release configuration in Visual Studio. You also have a master configuration. And if you pick debug or release configuration, it doesn't compile in all your project dependencies. So if you hand your app package to a tester or to a client, they won't be able to install it right away. So make sure you pick master build configuration to make sure all your dependencies come with it. Then also light matters in holograms. One might think that because I see through it into the real world and the real world has its own lighting, I don't need my own lighting, but that's not true because the HoloLens doesn't understand the real world lights. I mean, they're there, but they're not calculated into the experience. So I have to have an idea, a concept of my own light system that works with the environment the users are in. So that's a big one. Use UWP part of your app for data access. So if we build a holographic application, it's always a UWP app. But if you use Unity on top of it, Unity has its own mono engine. And sometimes we want to do complex operations, for example, data access. We want to do socket communication to have real-time communication between a HoloLens app and another controller, for example. Maybe we have a Surface controller app or a dial controller, whatever. Those things tend to be really hard to do in Unity, and they're relatively easy to do in UWP. So our strategy here would be to do as much as we can in UWP and then have a communication between the Unity part of the application and the UWP application and not try to do everything in Unity. That's saved us a lot of time in our last project. Choose the right build type for your app. So if you set up an application in Unity, you have two options how to output the application. You can either choose XAML, which is kind of the UI technology of UWP, or you can go directly for D3D, direct 3D. And this has implications on the feature set you can actually use in your applications. So if you're going for D3D, which is the default option, you will always have the best performance because it leaves out a lot of the XAML UI infrastructure. But you cannot do any sort of on-screen keyboard input. You can just do that if you use XAML output format. So that's some sort of decision you have to make upfront in your project. And the last one would be the one that had the biggest business impact for us is test early in your target environment. So we had an application that we developed in our office with a 1:3 scale model of an object that was part of the experience, and it worked perfectly in our setup in our office. Then we went to the client, and they had a special studio environment with very bright rooms, very bright walls, a lot of light in them, and the true scale model with a lot of reflections, and things didn't work at all. And it did cost us a lot of time to iterate through that, so it's really valuable to go ahead and test as early as possible in your real-world environment because HoloLens is really reacting towards its environment. Lighting does matter a lot and things like that. Another nice feature we're just starting to explore is the spectator view. Spectator view allows you to have a holographic experience that can be seen through a third-party perspective. You might have seen this experience if you have watched some of the Microsoft keynotes around HoloLens. You'll also see someone with a huge camera running around on stage, filming the scenery, and then allowing to have as a third-party perspective in HoloLens. They open source that technology, so everyone can build the solution like that. You can see our solution. We have a DSLR camera, and then on the flash adapter, there's sitting the HoloLens, and then we can combine the video image of the camera with the holographic layer, and then have a third-party perspective. That helps a lot if you want to do a video of the experience for your customer to really showcase it. So this is a little sample video we did of an application we're building for Steelcase. So this is the first-party perspective, and you can see now this is a spectator perspective. So you can actually really see what the people using holograms can see. And the other thing that's interesting here is there are actually two people wearing a HoloLens. So you can build holographic apps that actually share their holographic experience across multiple headsets, which again adds to the productivity value of the device. And then beyond HoloLens, there's an even bigger perspective or bigger picture here called Windows Mixed Reality. That's actually the idea behind HoloLens, is to actually have a real platform for mixed reality and holographics. And what you can see on this picture is on the right-hand side, there's the VR view of the holographic shell. On the left-hand side, there's the mixed reality view that you would have using a HoloLens. And the right-hand side would be enabled through new headsets that are coming up this year that are running on this mixed reality platform. And Windows Mixed Reality is shipping today with Creators Update. So if you have Creators Update installed, you also already have a mixed reality application. You have relatively low hardware requirements. It's not like an HTC Vive, so a lot more machines can run it. And you will have a choice of very inexpensive immersive headsets coming up, starting with $299 later 2017. And obviously, input would be more like gamepad mouse here. They're wired, but they run the same applications than the HoloLens. All right. I'll skip over those. Those are pure marketing slides. So where would you actually start? Obviously, grab the tools. There's a really neat online training course for beginners called the Holographic Academy online that gives you like a brief walkthrough for all the core features like spatial mapping, spatial audio, input, gaze, and everything like that. And then go from there. One GitHub repo I really want to point out is the Galaxy Explorer. That's an application Microsoft has built that is fully open source and really gives some nice insights. And you can go from there. So this is the very, very quick run-through of mixed reality and HoloLens. And with that, I would like to open up for questions and or live demos as you like. I'm here. I got two devices, so don't be shy. Okay, you have a couple of questions.
Yeah,
right?
not too many. So I have a couple of questions here that came in through the app. You touched on one of them very briefly with the shared experience, that multiple people could see the same thing. But this one does have a bit of a twist, like multiple people wearing the HoloLens, can they like interact with the holograms, all of them? Or is it like a master mode and then the other people can just watch? Or how does that work?
You can really have a collaborative experience. It really depends on how you implement it in your own app. So it's up to the developer how he builds it, but it's possible to do that.
The other question I have is, what's the battery life like on these things?
Okay, so on this device, it's if you go full brightness, doing a really expensive game, it's like 2.5 hours if you go full power.
I think that's what we have time for. Thank you very much. Please give it up for Philipp.
Thank you.